Okay, a question about force extension graphs and springs. So, first bit is this. This guy has measured a spring using these calipers. He's got 6 different measurements and we have to calculate the average length of the spring. Okay, it seems simple, right? If they ever ask you to do this in the exam, look out. One of these is probably anomalous. And if we look, yes, we have one there, 20.44, which is significantly different from the other 5. So they're looking for you to spot that and not use it in the calculation. So what you have to do is add up the other 5 and divide by 5 to get the average. And when you do that, you get 20.314 millimeters. And that's the correct answer. If you got 20.335, then you included that one and you won't get the marks. So that is what they're looking for. Okay, so keep an eye out for that. They shove in an anomalous result. Okay, next bit, this. Right, we have they give you a blank piece of graph paper and they ask you to plot the force extension graph. Force goes up the y-axis, extension goes on the x-axis, okay? So, they give you the weights and the extensions and tell you to plot it. So, how do you get the full marks here? Well, like I said, force on the y-axis, extension on the left. Label the axes, label it force and extension. Don't just write the numbers, label it. And include the unit, okay? Don't forget that. Now, on the graph paper, on both the x and the y-axis, there are 6 large squares, 6 divisions, okay? So that's what I've drawn here. So they're making it easy for you. The force goes from 0 to 1.2, so clearly the best choice is to have 0.2 per division, per large division. It fits perfectly. And again, they've made it easy for you on the x-axis. 24 and 6 divisions, well, clearly you do it every 4, 8, 12, 16, 20, 24, and it fits perfectly. So that would be how to do the axes, okay? Now, plotting it, you just have to be careful. Make sure you get the cross exactly on 0.2 and 4. It's very easy to lose marks here, they're strict, okay? So get every cross exactly, that one should be on 0.4 and 8, and likewise 0.6 and 12, and so on. Get every cross exactly correct. And if you do that, they should lie in a perfect straight line, okay? So get your ruler out. Don't do it by hand in the exam, okay? I know I've done this one by hand, but you have to use a ruler. Use a ruler, get it going through every point exactly, and make sure it goes exactly through the origin as well. It will do, because it's a dead straight line, it goes through the origin. Okay, so to get full marks in plotting a graph, you just have to be thorough and careful. Right. Next bit, the student writes, the extension of the spring is directly proportional to the weight stretching the spring. Okay? Comment on the student's conclusion. 3 marks. Right. So how do we get 3 marks out of this? Well, he said the extension of the spring is directly proportional to the weight stretching the spring. Okay. Is that a reasonable thing to say from this graph? Right. The first thing I'd say is that this graph is straight. It's a straight line. Okay? Second thing to note is that it passes through the origin. Okay? And then say that therefore The extension of the spring is directly proportional to the weight stretching the spring. Okay. Right. I've jumped slightly ahead. Therefore should be the fourth point. Okay. The third one is that these two conditions mean it's a directly proportional graph. Okay. So these two conditions mean it's directly proportional. Finally, therefore, the student statement is correct. Okay, and that'll get you the 3 marks, right? It's, you know, when you're sitting in an exam and you have to extract 3 marks out of a question like this, it's not easy, I realise. But that is how you would do it. Okay, say as much as you can. So these two things here, when you have a straight line, okay, that passes through the origin, that means you have a directly proportional relationship. You need to know that, so remember that, okay? Those two conditions are necessary and sufficient for direct proportionality, okay? Necessary and sufficient means it's just a slightly smart-ass way of saying you need to have both of them, but you don't need any more conditions to be directly proportional. Okay, let's move on. Right, the student investigates stretching wires. Describe, so that they hand you this, that's on the, you don't have to plot this, you've got that on the question sheet. And it says, describe the non-linear stretching of the wire. Right, so do what they tell you. They want you to describe the non-linear bit, okay? And that's this bit here. The straight line bit, that's the linear bit. So don't bother describing that, you won't get any marks. They've told you to describe the non-linear bit, which is this. And this is, again, it's worth 3 marks. So, how do we get 3 marks out of this? Well, as always, don't be shy about saying obvious things. There's a good chance to get the mark, okay? So, how would I do this? Well, first thing, so that is there, that's where it starts being non-linear. That's 37.5 newtons and 4 millimeters, okay? So, first thing, above extensions of 4 millimeters or loads of 37.5 newtons, there are large increases in extension for small increases in load, okay? Because it's got a low gradient, if you like. It's quite flat here, so you don't need much of a load to get a large extension. Okay, so in the exam you would write above extensions of 4 millimeters or loads of 37.5 newtons, there are large increases in extension for small increases in load. Okay, so I'll just summarize that quickly. So above 4 millimeters or 37.5 newtons, you get large extension for small load. So large increases in extension for small increases in load. Okay? Right, good. Right. That point there, it's about 16.5 millimeters. So just say that you get the maximum extension at 16.5 millimeters, which is when the wire breaks. Okay? It breaks at that point. That's why there are no values beyond that. Okay? keep going. So about here at 12 millimeters, it's the peak load value, which is about 46 newtons. Okay. So just it says describe it. So just say that at 12 millimeter extension, you have the peak load of 46 newtons. Okay. And there's one last thing we can say. It goes up and then down again. But don't say that, say it like that. You've got to say it in a physicsy science way. Okay? So, I think you should say something like this. Beyond an extension of 12 millimeters, the load is reduced from 46 newtons to 44 newtons, but the wire still keeps extending from 12 to 16.5 millimeters. Okay? You've got to say something about the fact that it goes up and then down again. The reason it does that is because you actually can, when you've hit that peak value, you can reduce the load a little bit. And because you're already in this non-linear region, it's the way wires behave when they're being stretched. It will still keep extending even though you've reduced the load. So, let's summarize that. So, beyond 12 millimeters, the load is reduced from 46 to about 44 newtons. So the wire still keeps extending. Okay, from 12 to 16.5 millimeters. That's a sort of physicsy sensible way of saying it goes up and then down again. Don't write it goes up and then down again, right? That's not good. Do it in a boring, sensible way like that. Okay. Thank goodness that question's over. They're so boring, these sort of questions, where you have to squeeze out 3 marks from describing and describing again. They're agony, okay? I hate them as much as you do. But to get through them, to get the maximum marks, you've just got to learn this sort of dry exam technique of saying the obvious, okay? And describing things in a sensible, physicsy way rather than, it goes up and then down again. And answering the question, describe you to do the non-linear bit, so don't describe the linear bit. Okay? And try and say 4 things if they're asking for 3 marks. Things like that. Okay. That's it. Good luck. I hope you can, you will get questions like this in the exam, and I hope you just get through them, use exam technique and get the marks and move on. Okay.